Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Hello everyone, thank you for joining us for week 28 of the Concentrator Talk call brought to you by the Oxygen Alliance. My name is Mwawi Lungu, and as usual, very pleased to be hosting the call. I am joined by my colleagues, Sharon Gozo and Timothy Mtonga, along with our usual technicians from OpenO2 and Sunrise. On the technicians panel today, we have Daphne Magela, Cynthia Chikomoni, and Linda Mishoni, who are joining in from Lilongwe, Malawi. And we have Masofa Mujaji joining us from Johannesburg, South Africa, and Kuinda Singh joining us from Chandigarh, India. So for those of you that may not be aware, the Concentrator Talk Call is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time. So here we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So in case you have any issues with regards to oxygen concentrators that you'd like us to help you out with, you can always send an email to us through our email address, info@oxygenalliance.org, and we will do our best to help you with your problem. So as usual, we'll also be having a topic of interest, and today we'll be discussing about zeolite. So we'll be talking about why we use a certain type of zeolite in oxygen concentrators. So Francis is going to take us through that. So we also have polls at the end of some of the questions, so please don't attend to them when they pop up. And for those of you that haven't shared with us your email addresses yet, please do so that we can add you to our mailing list, so that we should be sending you reminders and updates from the Oxygen Alliance. Okay, so now to jump on to our questions for today. So our first question says, I have recently started working as a nurse at St. Gabriel's Mission Hospital, and I was instructed to refill a humidifier bottle of an oxygen concentrator with distilled water. Why do we need to use humidifier bottles on oxygen concentrators, and why do humidifier bottles use distilled water instead of tap water or any other water? So I'll ask Cynthia to respond to this one.
Thank you, Maui. When providing oxygen therapy to patients, humidifier bottles are used to humidify the air, enhance moisture, and reduce the dryness of supplemented oxygen. The air produced by oxygen concentrators is dry, and prolonged exposure can lead to sore throats and sometimes nosebleeds. Increasing the humidity of this air prevents this. Number one, it prevents the patient's airways from being too dry when breathing directly from the concentrator. It keeps the nose, mouth, lungs, and respiratory membranes from drying out while providing long-lasting moisture for the greatest patient's comfort during therapy and medical procedures. The oxygen picks up humidity by flowing through the water bottles connected to the oxygen concentrators. Distilled water is made by boiling the water to steam, and this leaves behind impurities. The steam cools and condenses back into water and is collected. The collected condensed water is the distilled water. Hence, distilled water is used in humidifier bottles for the following reasons. One, is to help stop the growth of moths, and moth colonies are far less likely to be present in distilled water. Number 2 is that tap water contaminates the humidifier bottles with calcium, salt, and magnesium found in the tap water, which tends to block the air outlets in the diffusers. Number 3 is that the white humidifier dust that humidifiers produce is removed by the distilled water. The water is used in the humidifier bottles contains dissolved minerals from the humidifier dust. Thank you.
Thank you very much, Cynthia, for that explanation. I hope that was clear, but in case we have questions on this explanation, we are free to do so. One thing to just note is that there are situations where you can sometimes use a concentrator without humidifier bottles, but then it is advised that you should only do this when you are supplying oxygen at very low flow rates, so between 1 and 3 liters per minute, if I'm not mistaken. So if you are supplying oxygen to a patient at higher flow rates, then you just need to use the humidifier bottles. All right, so no question and no extra questions there. So we'll be moving on to our second question, which says, in our workshop, we have an AirSep Intensity 10 and a J5 oxygen concentrator, which are staying idle because the cooling fan for the AirSep is broken, and for the J5, it was misplaced. We have spare fans, but they are from other concentrator models. Can I install 2 of these fans in the concentrators? What are the things I have to consider before installing fans in the concentrators? So I'll ask Linda to answer this one.
Thank you so much, Maui. So every concentrator has a cooling fan that draws in ambient air into the unit in order to cool the compressor and internal components. Even though the cooling fans from different concentrators may look the same, you cannot just replace a fan in one concentrator from a different concentrator model. This is because the fans mostly differ in their operating voltages. So firstly, I recommend that you should know the power ratings of the cooling fans which are used in the concentrators you are working on. Some AirSep Intensity 10 concentrators use 220 volts AC fans, while other concentrators of the same model use 12 volts DC fans. And the J5 concentrator also uses a 220 volts fan and AC fan. So ensure that you check the power ratings labeled on the fan in working concentrators of the same model so that you can install fans of correct power ratings on those 2 concentrators. Another thing you must consider when installing the cooling fans in your concentrators is the orientation of the fans. The cooling fans used in oxygen concentrators have 2 arrows labeled on them. One arrow shows the direction of rotation of the fan propellers, and the other arrow is there to show the direction of airflow. In some concentrators, such as the DevilBeast 525, the cooling fan is there to pull hot air from the concentrator into the surrounding environment. So the arrow for the airflow on the fan for the DevilBeast 525 points away from the compressor. And on the other hand, the fan used in AirSep Intensity 10 is supposed to be drawing air from the outside into the unit. So for this concentrator, the arrow for the direction of airflow has to point towards the compressor. So as you can see in the graphics, we have 2 images. They are the images of a cooling fan which is used in AirSep Elite concentrator. The one on the left has an image showing the power ratings on the fan, and the image on the right just shows the arrows indicating the direction of airflow and rotation. I hope this helps you to solve a problem we are facing. Thank you, Maui.
Thank you very much, Linda, for that response. Indeed, I hope it's going to help to solve that. So as she explained, we just need to be very careful with how to orient these fans, because for some, you might orient it the wrong way and then it just messes up the functionality of your device. So we have a poll at the end of this question, and Timothy, if you'd please launch that poll.
Thank you, Maui. So I've launched the poll. Basically, in this poll, we're asking the audience if they have ever replaced the cooling fan in an oxygen concentrator before. I think you can just explain where to find the polls if anyone is not familiar.
Yes, so if you're joining us using a computer, then if you go to the bottom right of your screen, the icon on the far right is the activities button. So if you click on that one, a window will open up where the pause menu is one of the listed options. And if you're joining us using a mobile phone, then if you go on the options menu, it's also located on the bottom right of the screen. If you click on that, a window will open where you have the activities button as one of the options listed. And if you click on that, you should be able to see another window where the pause menu is also listed.
All right, so it seems like it's an even split with 3 people having replaced the cooling fan in an oxygen concentrator before and 3 have not. And I hope that the people who have replaced them in the correct orientation and using the right component like you have discussed in the previous answer. I'll now end the poll.
Right, thank you very much, Timothy. So we'll now move on to our next question. So the next question says, I was working on a Longfian J5 oxygen concentrator and I noticed that the nebulizer port was leaking. I was thinking of tying the pipe that connects to the nebulizer so it stops leaking because the oxygen purity at the patient outlet dropped to 49%. I was wondering if this is the correct way to solve the problem or if there were other ways because I don't want to permanently block the nebulizer port. I also wanted to know why the oxygen purity drops when the air is coming out of the nebulizer port. And finally, why is there a nebulizer port and what is it used for? So I will ask Daphne to respond to this one.
Okay, thank you, Maui. So the nebulization port is used for turning liquid medicine into a fine mist so it can be breathed in by patients. This is so that the medication goes straight into the lungs and respiratory system where it is needed. This is usually on patients with respiratory infections or diseases such as asthma, cystic fibrosis, or bronchiectasis. If the nurses are using the nebulizer port, they attach a medicine cap to the nebulizer port, and the compressed air is forced into the medicine cap, turning the liquid medicine into a mist, which is then delivered to the patient through a mouthpiece. If the nebulizer port is open, the oxygen purity reduces because the port receives air directly from the valves, reducing the amount of air going to the sieve beds. A reduced amount of air means a reduction in the pressure. So as a result, there isn't enough pressure for pressure swing absorption. Moving on to how to fix the leak. The Longfian J5 has a nebulization knob on the right, directly under the flow meter. So in the image, we can see the knob. It's a silver knob under the flow meter on the right, and the nebulizer port is the black one on the left, under the flow meter on the left. So this knob is used to control the flow of air through the nebulizer port. The knob can be used to close the ports. If the knob is tightened and the port is leaking, there might be a problem with the knob. You can open the concentrator and check if the knob is damaged. Sometimes the plastic barb fitting that the knob screws into has cracks and the knob fails to screw tightly, therefore making air leak. You can either replace the fitting or glue it so that the knob tightens. I believe that fixing the knob is the best solution to prevent permanently blocking the nebulizer port, like you said. Thank you, Maui.
Thank you very much, Daphne, for that explanation. So there was a time where I came across this one as well, and if you are not very careful, you can't really notice that the nebulizer knob is open, so you actually have to clearly listen to it. So as technicians, I think we just have to be very cautious and make sure we note everything going on with our concentrators, because you might not notice it and then it just affects the purity of your machine. All right, so if we have any questions on this explanation, we are free to ask, and then Daphne can respond to the follow-up questions. Okay, seems we don't have any questions there. So we'll be moving on to our next one. We have one Narena 5-liter per minute oxygen concentrator purchased 2 years back. It worked fine with periodic maintenance at regular intervals. Now the oxygen concentrator is not powering on. Please suggest a solution. So I will ask Kowinda to respond to this one.
Thanks, Mavi. So as the problem with the machine is that it is not powering on, so we will start from the power socket, checking the voltage availability with the multimeter. If available, now check the power cable either by the continuity, check with the multimeter, or voltage check at the point where power lead enters the machine. Now moving further by checking the power switch. So you can check the power switch by putting it on and to the continuity check, and also check the circuit breaker with multimeter. If all the above parts functions properly, now moving on to the PC board, as we can see in the graphics. So on the side, that with the yellow color transformer, that is the power supply mounted on the circuit board. So the PC board 12-volt power supply is mounted. Check if the output is coming using a multimeter, or any damaged part, if visible, maybe some resistance or fuse maybe there. If it is visible, you can check it. Either if we have a new power supply, so if available at our workshop, we can replace it, or if not available, so we can use a 12-volt power supply normally available in the local market to for the solution of this problem until the new part is coming from the manufacturer or somewhere. So we can use that also from the local market. So that can be the solution. Thank you.
Thank you very much, Kowinda, for that response. I hope that will help to solve your problem. And in case we have some follow-up questions on the explanation that he has just given us, we are free to ask those questions, or we can just paste it in the chat and then we'll respond to it. Okay, it seems we do not have any questions there, so we'll move on to our next question. So the next question says, I have a DeVilbiss 1025 machine with a very noisy compressor. Upon receiving the machine, the compressor made a squeaky sound. I then repaired the compressor and reinstalled it for testing. The compressor is now noisier than before. I reopened it and checked if I assembled it correctly, and it looks fine. I even checked the piston movement. It moves freely with no funny sound. Does this mean that the compressor is unrepairable and will have to be replaced? So I will ask Linda to answer this one.
Thank you once again, Maui. There are several things that cause the compressor to become noisy. The first one is worn out piston caps and sleeves. This is solved by replacing the caps and sleeves or cleaning the internal surface of the sleeves with a fine sandpaper. That is, if they are not badly worn out. The second thing is worn out piston bearings. These are bearings that assist the pistons to move up and down to compress and deliver air. If this is worn out, the compressor will have a harsh crackling sound. In this case, you will need to replace the compressor. Another cause it could be that the compressor was not assembled correctly, which when doing the repair. So to answer your question, no, it does not mean that the compressor is unrepairable. According to the explanation you gave, the compressor only had a squeaky sound, which is corrected by replacing the caps and the sleeves. Since you have checked the piston movements and the reassembly, it can be that the cap retainer is not as tight as it should be. You need to open the compressor, tighten the screws until the screw no longer has an allowance to be tightened further. It would be best to get a screwdriver with a point that fully flashes into the screw head so that it does not slip when you tighten, as this can damage the screw head and make it difficult to remove in future. Once you have tightened the cap retainer and the compressor is still noisy, then you can go ahead and replace the compressor. Thank you.
Thank you very much, Linda, for that response. So I actually came across a problem where we serviced a compressor. I think that was a GC 250, 28, sorry. But then we realized later on that the service kits that we used were slightly shorter than the ones that are supposed to actually go in there. So the rattling noise was actually coming from the sleeves because they were slightly shorter than what we had. So we had to open it again and fit in the right sleeves. So always be sure to check for these little things. Right, so if we have some questions that we'd like to ask from the audience, we are free to do so. Or if we have some further comments from the other technicians, we are also free to add on to the explanation. Right, seems we don't have any questions. So we'll move on to our next question now. So the question says, when I was working on the concept, what would be the cause and how may it impact the effectiveness of the zeolite in the sieve bed? So I will ask Cynthia to respond to this one.
Thank you, Maui. The first thing to check when the compressor of the oxygen concentrator overheats is the fan. Check if the fan is working to ensure adequate ventilation to let the heat produced by the compressor out. If the fan is not working, replace the fan with a spare fan and make sure that you place the fan so that it is blowing the air in the right direction in terms of where the air is blowing. So for example, in DevOps 515, the fan blows warm air from the compressor to the outside. So make sure that the air vents are not obstructed. In other models like AirSep, the fan blows cool air towards the compressor. So make sure that you maintain the direction when reinstalling the fan. The performance of the zeolite in the sieve beds to the absorption of nitrogen gets affected when the temperature of the air gets too hot or too low. Experiment conducted on the amount of nitrogen zeolite can absorb at high pressures show that the optimum temperature range for efficient nitrogen absorption is 50 to 60 degrees Celsius. So this means that the zeolite will be absorbed, will be less absorbed, will absorb nitrogen less when the temperature is not within the range So this will result in low purity even when it's at the right pressure. Thank you.
Thank you very much, Cynthia, for that explanation. I hope that will help to solve your problem, and I hope that gives you some knowledge on the effects of temperature on the zeolites. So if we have some questions from the audience or some comments from the other technicians or the other members of the audience, we are free to make those comments. All right. If we don't have any comments on that one, we will now take a short diversion from our questions, and we will now jump on to our topic of interest. So as I explained at the beginning of the call, today we'll be talking about the zeolites that goes into the oxygen concentrators, and we'll be differentiating why the different models take up different zeolite types. So Francis will be taking us through that explanation. So over to you, Francis.
Thank you, Maui. And the topic of interest today will be a discussion on the sodium-based zeolite and lithium-based zeolite used in oxygen concentrators. So oxygen concentrators use these two different types of zeolites. And firstly, we'll start by looking at what the pressure swing adsorption is, or the PSA process is. So the pressure swing adsorption, also known as PSA process, is a static separation of air gases via a specific molecular sieve designed to absorb nitrogen under high pressure. So air is composed of 78% nitrogen, 21% oxygen, and 1% other gases that can include argon, and other gases, let's just say like that. So in order to get the much needed oxygen, we have to remove the nitrogen so that we get a higher period of oxygen. So we can only get up to 95.6 because we don't necessarily remove the other gases like argon, carbon dioxide, or carbon monoxide, and etc. The molecular sieve that is responsible for getting out the nitrogen in oxygen concentrators is known as zeolite. So what zeolite is, zeolite are microporous crystalline aluminosilicates with unique properties and are therefore used in adsorption processes. So it is the chemical nature that allows us to use them to get the much needed oxygen for our therapy. And the different types of zeolites with two main types of zeolite molecular sieve used in oxygen concentrators. So this is the sodium type and the lithium type molecular sieve. And these two molecular sieves have some similarities and differences between them. So we'll look at the differences found in the lithium-based zeolite and sodium-based zeolite, and also the similarities as well. So looking at size, they have the same size, that is a diameter of 0.4 to 0.8 millimeters. So both sodium and lithium do have a range of around that size. And where you can use these types of zeolite, it is applicable to use the lithium-based zeolite in 1 to 20 liters per minute oxygen generators. And the sodium-based zeolite, it is applicable to use them in the 1 to 5 liters per minute oxygen generators as well. So in terms of oxygen concentration, what you can get when you try to use these two types of zeolites, the lithium-based and sodium-based, in both you can get up to 93 plus or minus 3%. So that is a maximum of 95.6% of oxygen purity. And in terms of looking at the last parameter, that being the adsorption pressure, they have differing adsorption pressures or minimum adsorption pressures. For the lithium-based zeolite, adsorption happens within 14 to 30 psi or 1 to 2 bars. And for the sodium-based zeolite, it happens between 20 to 30 psi, and that is 1.4 to 2 bar. So those are like the differences between them. but also they also have another difference between these two. So the other difference is that lithium-based zeolite has a nitrogen to oxygen selectivity level of almost 2 times higher than that of the sodium-based zeolite. So the nitrogen to oxygen selectivity level is or can be thought of the amount of nitrogen the zeolite can absorb compared to oxygen. So I know that's confusing, but then that what it means there is that when let's say, for example, we say this compound or this chemical or this zeolite has a nitrogen to oxygen selectivity level of 6, it means that if you supply it with air, which also has a combination of oxygen and nitrogen, it will absorb nitrogen 6 times compared to oxygen. So that also means to say that it does absorb nitrogen. But anyway, since we're looking at the differences of these two, it doesn't necessarily mean that sodium-based zeolite is actually bad. No, but both sodium and lithium-based zeolite have a superior nitrogen to oxygen selectivity compared to the equivalent products. That's why they're used in oxygen concentrators, as purity isn't sacrificed. So as already looked at on the table, you get 93 plus or minus 3% either way if you use sodium-based or lithium-based zeolite. So yeah, moving on. The first generation of oxygen concentrators used or still use sodium-based zeolite. Sodium-based zeolite is less expensive than lithium-based zeolite, but requires greater quantities to achieve the same performance. The lithium type zeolite molecular sieves are more efficient than sodium type zeolite molecular sieves. So this can greatly reduce the volume of the oxygen generators. That makes the oxygen concentrator smaller and easier to carry around. So as manufacturers started to focus on making smaller and smaller or more portable oxygen concentrators, they started using the lithium-based zeolite. This is especially true for the portable battery-powered or battery-operated oxygen concentrators with shorter straps. And lithium started to make its way into smaller flow models such as the Respironics Everflow, as well as the DeVille-based 525, which is the next generation after the popular 515 unit. So a good comparison in terms of understanding the quantity of zeolite used can be seen with these two models, that is the DeVille-based 525 and the DeVille-based 515 unit. If you look at the two sieve beds, they're visibly different in size and volume as well. The 515 bed is actually much larger than the 525 bed, but all these machines are capable of producing up to 5 liters per minute. And also, the other thing that can be noted is that they have different compressors, and there's two different compressors. For the 515, it uses the ZW370, and for the 515, it uses the ZW370, and for the 525, it uses the ZW280. The output pressures, the maximum output pressures of these two compressors are actually different, with that the 370 being much powerful than the 280. So we'll go on to talk about these, about the size of the compressors. But roughly we can say that for the 515, it uses about 1 kg of zeolite per sieve bed, whereas the 525 uses half of that. So since you have two sieve beds in the 515, that is 2 kgs of zeolite, and the 525 you use roughly about half, that is 1 kg of zeolite in both the two sieve beds. But you still end up producing the 5 liters per minute of oxygen still, and at the same purity 95.6 if both machines are new. Anyway, it is important to note that so the size of the two concentrators itself, they're also different. The 515 is much larger than the 525. So moving on, as a demand, the demand for increased for concentrators with flow rates greater than 5 liters per minute. So that means to say that as we needed more liters, for example, 8 liters or 10 liters per minute, manufacturers chose to use the lithium-based zeolite in those models. As if you wanted to get 10 liters with the sodium based zeolite, you need a much powerful compressor and a much bigger sieve bed, or just reducing the portability of the machine. So one thing that we can also look at is the timing and cycling of these two concentrators of between the sodium based, or maybe the of the 5 liter and the 10 liter equipment. For example, this timing itself has nothing to do with the volume, and it has more to do with the volume and size of the sieve beds and absorption pressure. So using the same model of compressor, it will take longer to reach 30 psi with the larger volume sieve bed than with a smaller volume sieve bed. So a good example to look at is the AirSep 5 liter and the AirSep Elite, which is a 5 liter model, and the AirSep Intensity, which is a 10 liter model. In these two concentrators, of course, for the AirSep Elite, the 5 liter model, you can find the Thomas 2669 in there, the compressor that is. But then in other AirSep Elites, the 5 liter model is the same. You find the Thomas 2650 model or 2660. And you also find the 2650 or 2660 in the AirSep Intensity, the 10 liter model. This just means to say that the power of the compressor is the same. You can use the same compressor in the 5 liter and the 10 liter model. But now what changes now is the size of the sieve beds and also the cycle time. So as the volume increases of the cylinder, for you to get the 30 psi, it will take longer with the same amount of output pressure from the same compressor than it will take you for you to get it with the smaller sieve bed. So looking at the sieve beds of the AirSep 10 liters and AirSep 5 liters, we can also see that visibly they are different in size, with the 10 liter model being larger and the 5 liter model being smaller. So the 10 liter model, what differentiates it from the 5 liter model, of course, is first thing is the flow, the output flow, and also the size of the sieve beds, and also the type of zeolite used in the sieve beds, because as already pointed out, the output pressure for the compressor is still the same because they use the same type of compressor in the AirSep 5 liter as well. So the AirSep 5 liter does work with the sodium-based zeolite. So we've also done extensive experimentation looking at the differences in purity across various cycle times with and without degradation. To a large degree, the optimal configuration does not really change between the concentrator models when sodium or lithium-based zeolite is used. So in terms of interchangeability of these two zeolites, it would be possible to put the lithium-based zeolite in an oxygen concentrator designed for sodium, but then that would be unnecessarily expensive because lithium-based zeolite is more expensive than sodium-based zeolite. So one could potentially use a smaller sieve bed if you want to use the lithium-based zeolite in the in a concentrator that was previously using sodium-based zeolite. But before we had access to the lithium-based zeolite, we did some experimentation putting the sodium-based zeolite in concentrators designed for lithium, such as the DeVille-BIS 525. But we had moderate success here, achieving purities around 78 to 80% in most cases. So looking at this is still lower than the World Health Organization standard, which is around 82 to 85%. So we never achieved 95% in models that are indigenously use the lithium-based zeolite, and we tried to use the sodium-based zeolite in them. So in summary, this should not be done, but otherwise it should be avoided. So coming this far, this brings us to the end of our topic of interest today, and over to you, Maui.
Thank you very much, Francis, for that wonderful explanation. I hope we have all learned a lot here. If we have questions from the audience, as usual, we are free to ask. And Francis will answer all the questions that we might have. I see we have a hand from Kelvin. Go ahead, Kelvin.
Hello, thank you for the opportunity, and thank you also for the presentation. It's quite informative. I only knew about the sodium-based zeolite. I didn't know about the lithium-based one. And the questions that I had, at least most of them have been answered, especially when it comes to cost. My concern was, is there a way of now disposing the lithium-based zeolite? Is there a recommended way of disposing it? The old zeolite.
Francis, do you want to respond to this one?
No. So can someone take it up for me?
Kowinda, do you want to give it a try? So he's asking of how we can dispose of the old or used up zeolite.
So there are some local instruction by the local bodies issued as per the countries. They can follow those. Otherwise, for easy disposal, we can put the lithium-based zeolite into the water in a bucket. So as we were advised by the supplier, so we are putting that zeolite to a bucket of water, and after the bubbles bubbles are stopped coming from that zeolite, we can dispose it anywhere. No? So that is we are doing, but there are some local instruction by the local bodies. So you can follow that.
So Kowinda, maybe just some clarification. So the water helps to like neutralize the zeolite, I would say.
Yeah. It helps to neutralize. We have asked this question from the supplier. They have given us that instruction.
Okay, great, interesting. Kelvin, does that answer your question?
Yeah, thank you very much for the answer. At least now I have an idea of what we can do with the used up zeolite.
Can I just chip in on this though?
Yes, go ahead, Jerry.
Thank you. So I think you have to be careful about how you add the water and add the zeolite. I don't think you should add water to zeolite. I think, as Kowinda was explaining, you start with a bucket of water and you gradually add the zeolite a little bit at a time, because if you add it all at once, it can react violently. So I think there's a process to be followed, and I think it would be important for us to make sure that Kelvin gets that right process, that we share that with him. Yeah.
Okay, great. Thank you for that addition, Jerry. Do we have any other questions on the topic that Francis has just presented to us? Okay, great. Seems we do not. So we'll get back to our questions. So our next question says, I am a technician at one of the community hospitals in my country. I was working on AirSep 525, and after I completed my work, I discovered that the OSD sensor had developed some cracks. I have no idea how this happened because I never removed the control board from the concentrator. Is this something that I should be worried about, or will I be able to run the concentrator with a cracked OSD sensor? So I will ask Masofa to respond to this one.
Thank you, Moabi. The OSD sensor is commonly found in the DeVille-based brands, and the OSD is used for oxygen sensing and flow sensing in a concentrator. The OSD casing is very fragile, and when working with it, you need to be very, very careful, as it easily develops cracks, as you have experienced. The cracks normally the cracks normally develop when you are removing the pipes from the sensor. Sometimes you get the pipes get stuck. In the process where you force them out, the sensor develops some cracks. Luckily, most of the time, these cracks start from forming from the inside, and the seals within the sensor is still maintained. But it is important to just verify that there is no leakage with some soapy water. Be very careful when checking the leak, as you do not want to cause any short circuit with the water. So this is something you should not worry much about, but you need to keep a close eye just in case the crack grows. Thank you, Moi.
Thank you very much, Masofa, for that explanation. I hope that helps to answer your question. And in case if we have some further comments from the audience or from the other technicians, please, you can come off mute and make those comments. All right, seems we do not have any comments there. So we'll move on to our next question. So our next question says, I am a female nurse at Nsanje District Hospital. I noticed that humidifier bottles have different colors, so they're either black or green. Is there any reason the bottles have different colors, or does it just depend on the preference of the manufacturer? So I will ask Daphne to respond to this one.
Okay, thank you, Maui. So the colors on the humidifier bottles mean something, and they're not just there for preference. The color of the lid has something to do with how you can clean the bottle before use. Humidifier bottles with a white or blue lid are autoclavable, and you can sterilize them in an autoclave according to sterilization procedures. Humidifier bottles with a green or black lid are, however, non-autoclavable and should be cleaned by soaking in 0.1% chlorine or any recommended solution for 15 minutes, while also using a syringe to assure that the solution goes to the lid and rinsing with clean water, as well as rinsing the lid with a syringe. With this being said, it is not a good practice to change humidifier bottle lids, as one might think the bottle is autoclavable while it's not. But it is okay to clean the autoclavable bottle with either 0.1% chlorine or any recommended solution. Thank you.
Thank you very much, Daphne, for that explanation. Actually, I was one of the people who didn't know this until now. So yeah, this is interesting information to know. So we have a poll at the end of this question. So Timothy, if you would please launch that one up, and I'll be voting no for this one.
Yeah, so first of all, and the question is basically, did you know that the color of the lid on the humidifier bottles has a specific meaning? And like you have said, this is not something that you can just easily know. And I was also not familiar with this one. And it seems like a lot of people were not familiar with it. There are 4 no's already, only 1 yes. Yeah, I don't think there are any more votes coming in, but the majority of people did not know that the color of the lid of the humidifier bottle has a specific meaning. So I'm closing the poll now.
Great. Thank you very much, Timothy, for that. So moving on to our final question of the day. So the question says, we have a zeolite 1025 model oxygen concentrator. When we put it on, it automatically switches off after 3 seconds. When we opened the machine and found the sieve beds, filters had failed and the sieve beds were leaking and the zeolite was filled in the rotary valve. Can you suggest a solution, please? So I will ask Kowinda to respond to this one.
Thanks, Mavi. So as mentioned in the question, the reason why the concentrator automatically switched off is that the rotary valve was not able to function due to leakage of the zeolite from the seabed. So zeolite gets to the rotary valve. The zeolite granules block the gears, and this causes the gears on the motor on the valve to get stuck. Sometimes there are situations where some moisture gets inside the rotary valve, and this causes the zeolite to form some paste which, after it dries up, solidifies and cements the gear in one place. To fix this, firstly you have to open the machine, then remove the seabeds, rotary valve, and the exhaust muffler from the WBIS 1025 KS. Now, firstly, refill the seabeds with the new zeolite material if available at your workshop. The reason why the zeolite spilled over is because either the filters failed or the end cap moved, and this caused the zeolite to flow back into the pipes. So make sure you change the filters and close up the seabeds nicely. If zeolite is not available, then replace the seabeds with new ones. And now open the rotary valve using the following tools: T25 top screwdriver, top 25 and top 10, and a flat screwdriver. The process for complete breakdown, cleaning, and rebuilding of rotary valve is available on the Oxygen Alliance YouTube channel. And if you can paste the link on the chat, please. So now there is possibility that the zeolite may have entered the muffler, as you can see in the graphics also, the muffler through the rotary valve. So open the muffler by clicking the locks available on the on it as it is shown in the graphics. So wash the filter inside the muffler with soapy water and again rebuild it after proper drying. Now reassemble the muffler, rotary valve, and seabed to the machine and check the functionality. This is common issue among WBIS 525, 1025 and the Canta concentrators. So if you encounter a similar problem, the solution should be the same. Thank you.
Thank you very much, Kowinda, for that response. Indeed, this is a common problem. We have actually encountered this, especially in the 525, because we have a lot of 525s this side, and the Canta. So for the Canta models, a certain group was doing some research, and they discovered that the original Sieve beds that came with the concentrators weren't designed nicely, so they had to send a request back to the manufacturer and they improved the design. So it's less common these days, but in the first models that used to happen. So if you happen to encounter that issue, please just follow the steps Kowinda just explained, and you should be set to use your concentrator again. So do we have any questions or comments from the audience or technicians? Please, we are always free to ask in case we have any. Right, it seems we do not have any questions. So this now brings us to the hour mark and to the end of our oxygen concentrator talk call today. I'd like to thank you all for joining us for the call. It's always encouraging to see you here. We always encourage you to ask as many questions as you can. You can either do that through our email address or during the call in case you have a question related to one of the questions that we have. So if you want to send questions to us, you can do that through our email address, info@oxygenalliance.org. So we also have a website where we post different updates from the Oxygen Alliance. We also post links to all our previous calls on the Oxygen Alliance website. And these links are linked to our YouTube channel. So if you just search for Oxygen Alliance on YouTube, you'll be able to get to our channel. And please don't forget to subscribe once you get to our YouTube channel. So in case it was your first time joining us, please share with us your email address in the chat, and that will help us to add you to our mailing list. So we'll be sending you reminders of the next Oxygen call, and We'll be sharing with you updates from the Oxygen Alliance. So please share with us your email address in the chat. And reaching this far, I would like to thank you all for joining us, and I wish you a great weekend, and we will see you again in our next call. Bye, everyone.